Jai Hind everyone. I'm Shruti Jain, Assistant Professor, MC Department, Ajay Kumar Garg Engineering College. The topic that I'm going to discuss today is the concurrency in operating system. The subject code is BMC 203 and the subject name is operating system. The students for which this topic is being taken up is MCA first year student, second semester. So let's understand first what are cooperating processes. So when we are talking about any of a process is something that enters into the system for the motive of execution. So a concurrent process, the execution of concurrent processes takes place. Concurrent means that multiple process enters into the CPU for execution and they get executed simultaneously. So the processes that are executing in the operating system, they may be either independent processes or the cooperating processes. The process is independent. We say that a process is independent if it cannot affect or it is being affected by any other process that is executing in the system. So we call a process as an independent process if it does not share any data, whether it is a temporary data or a permanent data that needs to be stored somewhere in the system, and it is not sharing anything with any other process. That process is known as an independent process. When we are talking about cooperating processes are those processes when it can affect or it is being affected by some other process which is executing in the system at that particular point of time. So any process which shares the data with other processes is a cooperating process. When we are working with the independent processes because they are not sharing any of the data, that is why these processes are not affected by any other process. But cooperating processes, they need to, it may be a possibility when a resource is being shared by some other process. In that case, they need to wait for a certain period of time so that the resource gets free from another process and then they can do the execution in the system. Now coming to what is concurrency in operating system, it is the execution of set of multiple instructions or maybe set of multiple processes at the same time. So this occurs when several process threads are running in parallel in the operating system. We go with the concurrency in the operating system to improve the CPU utilization, because if only one process would be running at a particular point of time, then it may be a possibility that the CPU utilization is very low. So these threads that are multiple threads that are running into the system, they communicate with each other process or maybe each thread through the concept of shared memory or the message passing. Now, because the concurrency results in the sharing of system resources, the system resources may include the memory, the files, the instructions, or the hardware resources. We generally get the problems like deadlock or resource starvation, or the process has to wait for a longer period of time in order to get executed in the operating system. So we have certain principles of concurrency. When we are talking about the concurrency, we are basically talking about the multi-core processors and the parallel processing, which allows the multiple processes or threads to be executed at the same point of time. That is, in that case, it is possible that more than a single process or a thread is accessing the same space in the memory or some declared variable in the code, or even attempting to read or write to the same file. So whenever we are talking about concurrency, we are only talking about multiple processes that are entering into the system for the execution. So the main problem that we get is when a process is entering into the system, we cannot calculate the time during which that process will complete its execution. So in that case, what happens is we need to have certain algorithms which will deal with some issues that these concurrency creates. So the amount of time a process takes to complete, it depends upon three following factors. The first one is the activities of other processes. Because we are saying that these are cooperating processes, In that case, what happens that the processes will be sharing the resources. If suppose I have a resource 1, this resource 1 is currently being used by the process P1. Now, I have another process thread P2 which also wants this R1 for its execution. So, in that case, this P2 has to wait until and unless P1 completes its execution and release the resource R1. So, it is not necessary that a process gets completed only during the time that it is to be complete, like the execution of that particular process is to be completed, but it also depends upon another processes, because the resources are being shared by these are being used by other processes also. The second thing is the way the operating system is handling the interrupt. It is not necessary that the process would only be using the CPU for the execution. It may also need certain IO devices or maybe some other devices where the CPU execution is not required. So, in that case, it depends upon the operating system how it handles those interrupts so that the processes gets executed timely. The next, the scheduling policies of the operating system. We have certain scheduling algorithms on the basis of which the process gets executed in the operating system. So, it also depends upon the scheduling policies for the operating system. The one problem that we will discuss today is the producer-consumer problem, which comes under this concurrency control. Now, when we are talking about the producer-consumer problem, the producer-consumer problem is a problem wherein we have two types of processes. The first process that we have is a producer and the other type of process that we have is a consumer. It is a multi-process synchronization problem wherein, as the name suggests, the producer would be producing something and consumer would be consuming those items which the producer is which the producer is producing. So, here what we have a same memory buffer which will be shared by both the producer and consumer, and this memory buffer will be of the fixed size. Suppose this is a memory buffer which has certain slots into it. This memory buffer will be shared by the producer as well as by the consumer. So, these are the processes which are concurrently running and are cooperating processes. If one process would be running, the other process has to wait till the first process completes its execution for that particular time being. So, if we talk about, if we get the introduction to what the producer-consumer problem is, the first thing is the producer will always be producing something. Now, when the producer is producing something, in that case, the items will be added into the memory by the producer. The producer will always be adding some elements into the memory buffer and it will stop its production only when the buffer is full. When the buffer is full, in that case, the producer has to stop because we do not have more space for the producer to produce the items. So, in that case, the producer has to stop its production. When we talk about consumer, so when the producer is producing, the items always get incremented into the buffer. When the consumer is consuming the items, the consumer would always be reducing the items from the buffer which the producer has produced. So, when the consumer is consuming, the buffer would keep on reducing. The data items in the buffer would keep on reducing and the consumer would be consuming till the time there are 0 elements in the buffer. So, the consumer would stop when the buffer is empty, and the producer will stop when the buffer is full. These are the basic conditions for the producer and the consumer. So, producer keeps on producing the items till the buffer is full and it will stop. It is not necessary that it has to stop only when the buffer is full. It may be a possibility that the producer stops in between also. But the maximum limit for the producer to produce an item is till the time the buffer is full. Once the buffer is full, the producer cannot produce because the buffer is of fixed size. Similarly, the consumer can consume the items till the time the buffer is empty. Once the buffer is empty, the consumer has to stop, though the consumer can stop in midway also. So, accessing the memory buffer should not be allowed to the producer and consumer at the same time. As we discussed, either the producer would be producing at a point of time or the consumer would be consuming at a certain point of time. So, we have a code for the producer and consumer over here. The code explains as we have a count variable which will keep a count how many items are being produced by the producer. When the code starts with, we have an item which is to be produced. The item to be produced will be for the producer and item to be consumed will be for the consumer. So, the producer produces the item. It enters into an infinite loop. The producer produces an item. Once the producer produces an item, it will check whether this count is equal to the buffer size, that is n. If count value is equal to the buffer size, in that case, it cannot add the item into the buffer because the buffer is already full. This n is basically the buffer size. So, here we have 1, 2, 3, 4, 5, 6. So, the value of n is 5 because we start with 0, 1, 2, 3, 4 and 5. So, we'll check if the value of count is equal to the buffer size. In that case, the producer has to stop the production and it will keep on waiting. Once the buffer is empty or there is slot for the buffer to produce an item and to add it, what we'll do, we'll add an item into the buffer. We'll input an item into the buffer. As soon as the item gets inputted, this statement is because the items would be removed from the by the consumer also. So, we need to find out a particular space for the consumer and the producer to identify whether the buffer is, whether there is a space in the buffer or not. Once we find out the space for a particular item to be inputted, the count variable will increase and it will again keep on producing till the time this count is equal to n. That is why we have a semicolon over here. This semicolon says that if the value of count is equal to n, the producer has to wait over here till the time the consumer consumes an item and there is a space left into the buffer to input an item that is being produced by the producer. Now, let's come to the consumer code. The consumer code again talks about an item C which the consumer has to consume. It enters into the loop and it will check whether the count is equal to 0 or not. If the count is equal to 0, in that case, the consumer has to wait till the producer produces the item. So, here again we have a semicolon which says that the consumer will keep on waiting till the time the value of count is equal to 0. Once the value of count is different from 0, that is, it is incremented, that means that the consumer can consume an item and the count can be decreased. So, in case there is an item into the buffer, in that case what will happen? The count will not be equal to 0. Once the count is not equal to 0, this condition becomes false and the consumer enters into the next statement. The consumer enters into the next statement and it says the buffer out. It will consume an item. Once the item is consumed, again we check a condition from the location from where the consumer is consuming the item and then the value of count decreases. So, this process keeps on going till the time the value of count becomes 0 for the consumer and the consumer has to wait for the producer to produce an item. Once here the consumer is waiting, now enters the process of producer. Now, the producer will check whether this condition is true or false. As soon as the condition is false, because currently the count is 0, this condition becomes false, the producer keeps on producing the item. And hence, the producer and consumer will be working separately. Once the producer is producing, the consumer has to wait, and when the consumer is consuming, the producer has to wait till the time the consumer releases the resources. The next thing that we have is inter-process communication. The inter-process communication talks about it is a set of mechanisms or the techniques which are being used by the operating system. It facilitates the communication and the exchange of data between different processes which are running concurrently on the computer. Now, if we look over here, we have the producer and consumer both working together. So, we need some mechanism so that they can communicate with each other and they can identify whether the buffer is available for the producer or the consumer at a particular point of time. So, in a multitasking operating system environment, the multiple processes, they may need to communicate with each other to coordinate with the activities, share the resources and exchange the information. The IPC mechanism, it provides a means for processes to communicate and synchronize their actions effectively. So, when we are talking about the inter-process communication, we have two fundamental models on which we'll be focusing. The first one is the shared memory and the second one is the message passing. So, when we are talking about the shared memory, the shared memory model is, the shared memory is a region of that memory that is being shared by the cooperating processes, and this region of memory is being established by the operating system. And at this particular place, the processes can exchange their information by either reading or writing the data into the shared region. So, shared memory, as the name suggests, is a place where different processes can exchange their information. They can read the data or they can even write into that memory. Then we have a message passing model where the communication takes place through the messages which are being exchanged by the cooperating processes. We have the diagram over here. So, when we are talking about the shared memory, we have the two processes, process A and process B, which are concurrently running into the system. They are cooperating processes. So, this is the shared memory which is available for process A and process B. So, whatever communication happens between the process A and process B happens with the help of this shared memory. When we are talking about the message passing, the messages are passed by the process A and process B. In this format, we have a queue of the messages maintained. When the process A enters any of the message, that enters into the queue. The process B also enters a message. Now, they both communicate with the help of this message queue. The communication establishes over here with the process A and process B with the help of the message queue. Here, it occurs with the help of the shared memory. So, if we talk about the concept of cooperating processes, here we can take the example of the producer-consumer problem as we have just discussed. Here, the compiler may produce the assembly code that has to be consumed by an assembler. So, here the producer is the compiler and the consumer is the assembler. Till now, we were only talking about the terminologies of producer and consumer. Let's take an example of assembler and the compiler. So, here the compiler is producing something, the assembly code. This is a producer and it is being consumed by the assembler and hence it becomes a consumer. Now, what assembler in turns do, it may produce object models that are being consumed by the loader. So, it is like the producer produces something, the consumer consumes, and then again the consumer is producing something and it is being consumed by some other process. So, when we are talking about it, we have one solution, that is the shared memory. So, to allow the producer and the consumer processes to run concurrently, we must have the buffer of items as we have discussed that can be filled by the producer and that can be consumed by the consumer. So, this buffer will be residing in the shared memory space and it will be shared by both the producer and the consumer. But this sharing is to be synchronized. It should not be the case that the producer is adding on something and the consumer is not able to consume anything. So, when we are talking about the shared memory, we need to have two types of buffers. The first one is the bounded buffer and the other one is the unbounded buffer. So, when we are talking about the bounded buffer, we just took an example in the producer-consumer problem over here. This was the bounded buffer which was of fixed size and the producer knows till what time it has to produce, and once the buffer is full, the producer has to stop over there. And same is the case for consumer. The consumer will keep on consuming till the buffer is empty. So for consumer, it is not a problem, but for producer, it is a problem because once a buffer is full and it is of fixed size, the producer has to wait. The unbounded buffer is just the opposite of it, where the size of the buffer is unlimited and the consumer may have to wait for new items and the producer can keep on producing because it is of no fixed size. Because there is no fixed size, the producer will not know where it has to stop items to be consumed. So this is a problem when we are having the unbounded buffer where the consumer can wait indefinitely. And the producer is producing something. But this problem can be overcome when we are working with the bounded buffer in the producer-consumer problem. So if we look over here, we have discussed today the two major things. The first one is the cooperating process, how the cooperating processes works in concurrency when several processes are running together. When we were talking about this concurrency, we talked about the producer-consumer problem. The producer-consumer problem is a problem where the producer is producing something and the consumer is consuming. In this case, they are using the shared memory, which is of fixed size. It could be of unlimited size, but there the consumer has to wait for indefinitely for the producer to stop producing. So we normally use a shared memory, which is of fixed size, where the producer produces till the buffer is full. It stops producing and the consumer can consume till the buffer is empty. This shared memory concept comes with inter-process communication, where the two or more processes are communicating either by the message passing or by the shared memory. That is all for today.